Okay, this little quiz review, we're going to be going over graphs of equations and then a couple story problems. So the question is this going to be a U or is it going to be a line? Well, the x variable, y is by itself, okay? The independent variable x is to the second power. Well, that means it's a U, okay? So we need the three coordinates to find the U, to sketch the path of the U. And this middle one is known as the vertex, okay? That's going to be the middle of the U. We have to know that point. Okay, so a parabola, a quadratic equation can be in the form, when we graph it, could be in the three forms. It could be an ABC, that's called standard form. It could be an AHK, that's called vertex, because the vertex is super easy to find. Or it could be in factored form, where the opposite of P and opposite of Q give you the zeros of the function, okay? Or if there's no second power, it's a line, but this one's to the second power. That looks to me like it's an AHK form. So A is -2, so you can expect the parabola to go like this instead of like I have it. AHK, okay? So, the vertex, opposite of H finds the vertex, as you can see right there, okay? So the opposite of positive 4 is -4. Then to get the other two, we're going to take -4 and we're going to add and subtract 1. So -4 plus 1 is going to be -3. Then -4 minus 1 is -5. Okay, so now I substitute -3 in for x first. So to find the y, this is the input, y is the output. So -2, -3 plus 4, second power, and then -2, so I got -4. Now I click up, and then -4 goes in for x. I got -2. I click up, and -5 goes in for x. Okay. So -3, -4. Okay. 1, 2, 3, 1, 2, 3, 4. Okay, -4, -2. 1, 2, 3, 4. That's -4, -2. Then -5, -4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay. Okay, now we have to label the vertex because this does have a domain, a range. Okay. -4, -2 is the vertex. Okay, so the domain we don't need, well, it's all, because x can be anything. It's more of the range that we're worried about. So we take the y with its -2, and from there it's going down, because when you look at these are less than -2. Okay, -2 is a king, so it's got to eat -2. He sits right up here on its throne. Okay, number 2, y equals 3x to the second power minus 6x plus 10. Now, we have x to the second, so it forms a u. Okay? Alright, so we need three coordinates. Okay, alright, so ABC, because it's clearly x second, x, and a constant. So the way to find the vertex is that formula taking the opposite of the b, dividing it by 2 times a. Okay. Okay, so the opposite of the b is going to be positive 6. Okay. Or excuse me, I don't put that there, that was stupid. Opposite of b is positive 6, and then that's divided by 2 times 3. Sorry about the stupidity. So 2 times 3 is 6. So 6 divided by 6 is 1. Okay, so we have 1. That's your vertex, not 6, okay? So we take that 1 and we add and subtract 1. So 2 plus 1 is 2, and then 1 minus 1 is 0, okay? Then you substitute those in for x, okay? So 3, 2 to the second, minus 6, and then 2 plus 10. So I got 10. Now click up, and we're going to replace the 2's with 1's. That's going to be 7. And then we're going to replace the 1's with 0's. That's your third coordinate. 10, okay? Okay, so 2, 10, okay? This is x, this is y. So we'll go by 1s on X, but to hit 10, you're going to need to go by 2s on Ys. If you're over 9 in your Y outputs, you're going to have to go by 2s. Okay, so 2, 10, 1, 2, 10. Okay, 1, 7, 1, and then 7. 0, 10. So 0, this is a Y-intercept. Okay. Okay, so plot your or label your vertex 1, 7. So the domain's all, but when I do my range, that's the Y, 7, and you're going up. Okay, it's so going upwards. So, and also these 10s, you know, if you put a 10 where instead of Y, it'd have to eat 10, wouldn't it be? So it eats the Y. Okay. Okay, number 3, Y equals negative 1/4 X plus 6. Now, Y is here. That's your dependent variable. Depends on X. X is not to the second, so it's a linear equation. Okay. So, you can cross out domain and range. We ain't doing that on a line. So you get Y by itself. If it's not already, it already is. Then you mark your MB. And that would be slope, Y-intercept. So negative 1/4 and then positive 6. So on the Y-axis, 1, 2, 3, 4, 5, 6. And then from there we go down 1, forward 4. Alright, and that's just a straight line. So having an X just to the first power is a linear equation. Okay. And number 4 is the same thing. I mean Y, but it's dependent on X, but X is not to the second power, so it's just going to be a line again. So Y is by itself, so you have your M and B, MX plus B. So the slope and the Y-intercept, and we don't need domain and range. Slope is 2 over 1, and then minus 3 is your Y-intercept. So 1, 2, 3, then up 2, forward 1. And that's just a straight line. Okay, next one, Y equals negative 2. Y is by itself times X plus 3 times X minus 5. Now, this is X to the second, because if I made you FOIL this, okay, you'd get X to the second. So it's a U. You don't want to FOIL it, okay? It's in a form we can deal with. And so it's 3 coordinates, with the vertex being the middle, okay? So this is AXY. XY, XY. So that's my A, because all these have A, and this would be followed with PQ, okay? Okay, so opposite of P would find that, and then the opposite of Q, and you do your vertex last, okay? You're going to add these coordinates and divide by 2. Now, the reason you do that, because the opposite of P is negative 3, and the opposite of Q is 5. Because you see, negative 3 plus 3 is 0. So if one of the 3 factors is 0, then the whole value for Y is 0. And then if I put 5 in for X, that 5 minus 5 would carry that to 0. So the whole product's 0. So those are your X-intercepts. 1, 2, 3. And then 5, 0, 1, 2, 3, 4, 5. Yeah, the APQ factored form always tells you what the X-intercepts are. Now, somewhere the vertex is going to be in between them, right in between them. It's symmetrical. So negative 3 plus 5. So negative 3 plus 5 is 2, and then 2 divided by 2 is 1. So then I replace both the x's with 1. So 1 plus 3, 1 minus 5. That's 32. Okay, so we have to, on the y-axis, okay, I have to get to 32. 5, 10, 15, 20, 25, 30, 35. Okay, so 132. Okay, so 132. Domains all. Okay, the range 32. And then from there it's going down. Okay, because these zeros are less than 32, obviously. Okay, so less than or equal to. Okay, now we have 2x plus 5y equals 20. Okay, all right, so I don't even have the y by itself, so first I need to isolate the y so it's by itself. Now, it's going to be a line because even when I get the y by itself, that x is not going to become a second power, it's a first power, okay? So it's a line, and we have to get the y by itself because you see, you have to get y by itself if it's not already. You don't have to do the domain and range, but we have to isolate the y variable. So variable we're isolating, here it is, it's got times 5 and plus 2x. You don't want to put a dot between the 2 and the x because the x isn't what you're trying to isolate. You're trying to isolate the y variable. I mean, usually when I solve for x, yeah, I'll put a dot, but I'm not getting x by itself, it's y. So I minus 2x, and then I make 0x and minus 2x. Okay, because these are not like terms, so x needs its own column for the terms. So 5 times y. So it's going to be negative 2x plus 20. Now we divide everything by 5. So y equals, negative 2 divided by 5 is decimal, so I don't want to deal with that. It's negative 2/5 x, and then 20 divided by 5 is 4. So you got MB, okay? So now we know our slope is negative 2/5. And the y-intercept's positive 4. So it's like the y-intercept is your starting point at 4. And then from there, every time we increase by 5, the function drops by 2. Anytime the x would increase by 5, the y would go down by 2. So down 2, 1, 2, 3, 4, 5. And you really can't, 1, 2, you can't do it again, so 2 points is good enough. Again, there is no domain, well, the domain range for a line is just unrestricted. Okay. Okay, now story problems. A golf ball is hit off the ground with a velocity of 100 feet per second. Find the golf ball's maximum height. So you're finding the maximum height. So I know that to find a maximum of anything in algebra class, okay, the math formula is opposite of the b divided by 2 times a. Now, draw a picture that with the maximum. It's called the maximum picture, okay, vertex. So this is figured out. We already know how we're going to find the x, opposite of the b divided by 2 times a. Now, so you're going to put equals y, and then you're going to go to an x to the second, because anytime I have a quadratic parabola, it's x to the second, plus x plus constant. So this is your gravity term, and that's negative 16. Now, this is your per, that's your rate, okay? And your rate's 100. And also y, sorry, before I even did this, I should have put above y height, okay? Y is whatever you're finding the maximum of. Okay, then my per is 100, and you're like, well, what's your constant? There is none because you hit it from the ground. So 0 feet's where you started. So you can put a 0 in there, but then you eliminate that, okay? Get that out of there. So it's A and B, that's all I need. I don't really care if the C went away because it's opposite of B, so plus 100. And then 2 times negative 16, negative 32. So I divide negative 100 by negative 32, 3.13 seconds, okay? Then y is your height, so then I put 3.13. Okay, then you just plug that in. Okay, 156.25. Okay, then our last problem is another maximum, but it's not maximum height. It's a community theater sells 150 tickets to a play when it charges $20 per ticket. For each $1 decrease in price, they think 10 more tickets will be sold. Find the maximum revenue the theater can earn. Okay, so you're finding a maximum again, and that's opposite of B divided by 2 times A. Okay, so I'm finding the vertex. Okay, so I know how I'm going to find the x, opposite of the b divided by 2 times a. Okay, now x second, x, the constant equals y. Now y is no longer height, y is revenue. Okay, now the formula for revenue is taking the money that I'm charging, which changes by the way, times the items that I sell. Okay, but it changes, so it's a complex expression. So I'm going to make myself a table to know how to fill that out. So dollars and items. So dollars is 20, the items is 150. Then $1 decrease in price minus 1 and then plus 10. 20 minus 1 is 19. 150 plus 10 is 160. 18, 170. Okay, and that goes on because see what's happening. You don't need to write these numbers down. To find the revenue when I'm charging $20 for 100 for each item for 150, 20 times 150 is 3,000. But then when they decrease it by 1, 19 times 160 is 3,040, so it went up. Okay, then 18 times 170, 3,060. So as you can see, it keeps on going up. Okay. Now I need to find when it maximizes. Okay, when it maxes out. Okay, because it's going up. I don't know when that's going to stop going up. It stops going up at some point. There it is, right there. Okay, so money, you got 20 and you have 150. Then minus 1x, and then plus 10x, because we don't, x stands for how many rows down we'd be going from the initial amount. That doesn't really count as a row. That's 1, 2. It's like jumps, changes. Okay, so we have to execute the FOIL method. So 20 times 150, 20 times 10x. Now if you don't, now that's done, but when you distribute this, if you don't put negative 1x, it's done. Okay, you have to get the 1x in as a negative. So 100, see minus, when I'm multiplying something with a minus in front of it, it's a negative value. So 20 times 150 is 3,000. 20 times 10 is 200. Negative 1 times 150 is negative 150, and then negative 1 times 10 is negative 10x to the second. So negative 10 is your x second, remember negative. Then you combine your x's, and that's 50. And then 3,000. You can label that C, but we don't really have a use for C because it's just opposite of B divided by 2 times A. So the opposite of B is negative 50. And then 2 times negative 10 is negative 20. Now I divide these and I get 2.5. Now you're like, well, how is that possible? Actually, it is possible because you'd go 1, 2, you go 20 to 19. Okay, 20 to 19 is 1. Okay, 19 to 18 is a second jump. Then I wouldn't go to 17. I'd go in between. I'd drop the price by $2.50. Okay, changes. You can do half of a change. You just, instead of changing it by, you change it by $1, then 50 cents. So yeah, that's possible. So then we plug in 2.5 for x, because we have to find the y. The y is what we're finding, the maximum revenue. Okay, so I substitute that. 3,062.5. Okay, so money. There's your money.